take dilute HCl into the test tube. So this is dilute HCl. So today we are discussing properties of dilute HCl using litmus paper. Already you know that blue litmus changes to red when you dip the litmus paper into the what we call as solution, that is dilute HCl. So you can see, you can observe that blue color of paper, that is blue litmus, changes to red. What it indicates? The given sample is acidic in nature. Okay, so this shows that the given sample is acidic in nature. So suppose if you use red litmus, okay, it will not show any changes because red will not change into blue in acidic medium. So it is possible only in the basic medium. So this is the first parameter. Next one, that is zinc metal. So next one is zinc metal. Using zinc metal, so take a zinc metal. Okay, this is zinc metal. Okay, zinc metal. Take, this is zinc metal. Zinc metal. Okay, take this zinc metal. Okay, then add this zinc metal into the test tube. Okay, then slowly dropwise or along the test tube you should put HCl. Okay, slowly it has to be done. Okay, slowly you can observe the brisk effervescence. It is coming slowly. You can observe, I think bubbles are coming out of zinc metal. You can see. So bubbles are coming out of it. What are those bubbles? Hydrogen. HCl I have added. What is the reaction? Zinc plus HCl gives rise to zinc chloride and hydrogen gas is coming out. See children, hydrogen is coming. Yes. Okay, so this is how you can see it will be faster after some time. The bubbles which are coming out of zinc metal will be more because the reaction begins. Now it is a slow. Afterwards zinc reacts vigorously with the HCl and bubbles are coming out. I think you can see small bubbles are coming out of it. Barta ide? Yes sir. What are those bubbles indicates? Hydrogen. So hydrogen is gas coming out of it. If you hold with the thumb, okay, after some time it will push because hydrogen gas is coming out of it. Okay, and even if you use matchstick, if you hold it near the mouth of a test tube, you can observe pop sound. That is because of hydrogen that is going to come out of it. See, the bubbles of hydrogen gas are coming out of it. So that is when zinc reacts with the HCl, that is a dilute HCl, it is going to convert into zinc chloride and hydrogen gas is liberated. Got my point? Next we'll take very important, that is lime water test. That is lime water test. So for experiment always we have to use dry test tube, dry clean test tube. Okay, so in the beginning only you can take lime water. So this is lime water. Okay, take lime water. Lime water into test tube. Okay, keep it like this. Then you take sodium hydrogen carbonate. You take pinch of sodium hydrogen carbonate. This is sodium hydrogen carbonate, and even you can take sodium carbonate also, no problem, because that also gives carbon dioxide. Then what you are supposed to do, add slowly dilute HCl to it, slowly, not see, vigorously it reacts. That is, it reacts vigorously and hold the mouth of the test tube like this. See, what are these bubbles? Carbon dioxide. The bubbles of carbon dioxide is coming out of it, and you should hold mouth of the test tube like this. Why?
To collect carbon.
Yes, CO2 should not go out of it, because I want to transfer that CO2 to this test tube. So, in beginning, the color of this test tube is colorless, but after some time, it turns milky. Slowly it turns to milky. See, bubbles of carbon dioxide. See, slowly it is, actually in the beginning it is colorless, now it is, so after transferring CO2 to the lime water turns milky. If you pass excess of CO2, what happens?
So color disappears.
Color disappears. Okay, so lime water, what is the color in the beginning? Colorless. Okay, now
Milky.
so this is lime water test. What do you call for this?
Lime water test.
Lime water test. So what we have done, we have taken a blue litmus. Okay, if blue litmus paper is available, you can take blue litmus paper. If solution is available, you can take blue litmus solution also. Then put a drop of that into the acid. What happens? Blue changes to red. That indicates that given sample is acidic in nature. Okay, and we have taken the zinc metal. So this is zinc metal. Then to the zinc metal, if you add dilute HCl, what happens? Zinc reacts with the HCl, convert it into zinc chloride, and hydrogen gas is liberated. Okay, if you hold the if you burn mastic and hold it near the mouth of a test tube, so it gives pop sound. That is, because of hydrogen, it burns with a pop sound. Okay, and the third one what we have discussed is we have taken sodium hydrogen carbonate, that is NaHCO3 into the test tube. Then we have added dilute HCl to it. What happens? During the reaction, carbon dioxide is released. Then we have passed that carbon dioxide into lime water. What is the color change in lime water? Colorless to milky. That indicates that CO2 is present and confirmed. The same practical you will do it in PUC also. Radical analysis, CO2 lime water test you will do in PUC also. That is why this is very, very important. That is a lime water test. Got my point? So this is properties of dilute HCl with blue litmus paper and with the zinc metal, and then with the sodium hydrogen carbonate. Same parameters, we'll do it for NaOH. So this is sodium hydroxide. Yesterday I told you this is NaOH, sodium hydroxide. So I have prepared the dilute sodium hydroxide. This is NaOH. Dilute NaOH. So dilute NaOH, that is the sodium hydroxide. Same experiment we'll do it with the what? Sodium hydroxide, that is dilute sodium hydroxide. So what we have to do is same, you can repeat the experiment with the litmus paper. Okay, for this you cannot use blue litmus. Why?
It is in basic.
No changes. Why? Because the sample is acidic in nature. You can use red litmus. Just put red litmus. What you will observe?
Blue.
Red to blue. What it indicates? Basic. This is a second experiment. Okay, that is with dilute NaOH. red litmus changes to blue, RB, that is red to blue, is basic in nature. So this is how you can observe red changes to blue in base. You can use any base, you will get the same result. Okay, but this I have taken NaOH, that is a dilute NaOH. Next is let me take zinc metal again. Okay, so I'll take a zinc metal, then I'll put the dilute NaOH to it. Okay, yes, take a test tube, dry test tube. To that you add sodium hydroxide to it. That is NaOH, that is sodium hydroxide, reacts with zinc and converted into sodium zincate and hydrogen gas. It will be a slow reaction. Slowly the bubbles of hydrogen gas is going to come out. Here what happens? Sodium reacts with zinc metal reacts with the sodium hydroxide, converted into what? Sodium zincate. Then hydrogen gas is liberated. So you can observe the bubbles of hydrogen gas which are coming out of it. That is see, slowly one bubbles are coming out of it. That is hydrogen gas, that is sodium hydroxide, that is dilute sodium hydroxide reacts with the zinc metal, converted into sodium zincate with the liberation of hydrogen gas. Okay, but in HCl you can see sodium zinc metal with HCl converted it into zinc chloride and hydrogen gas. Okay, we'll observe definitely that bubbles will come. Okay, it will be a slow reaction, but definitely the bubbles of hydrogen gas will come out of it. So that hydrogen is going to be liberated. In exam also they will definitely ask. Okay, in theory part also I think we have studied the same thing. What happens when metal is made to react with a base? What happens when metal is made to react with the acid? Same explanation you will give. Okay, generally you are going to tell them that salt will form on the liberation of hydrogen gas, but when you take particularly zinc metal, zinc reacts with the dilute HCl, converted into zinc chloride and hydrogen gas. If you use sodium hydroxide reacts with the zinc and converted into sodium zincate with the liberation of hydrogen gas. Respective salt will come with the liberation of which gas? Hydrogen gas. Next we'll take the very important one, that is lime water test. Even lime water test you cannot do it for sodium hydroxide. Why? NaOH reacts with what we call it as dilute NaOH, but you will not see any lime water test. So no reaction is observed. I will do that one also, don't worry. Okay, we'll take sodium carbonate or sodium hydrogen carbonate also. Okay. See, no bubbles, no brisk effervescence. No bubbles, no brisk effervescence means CO2 is not coming out. Why CO2 is not coming? In this reaction, it will not show the property as that of a dilute HCl. But in dilute HCl, which reacts with the sodium carbonate or bicarbonate, CO2 is the product. Here, no reaction. See, no changes in the reaction. What it indicates? With the sodium hydroxide, with the sodium dilute sodium hydroxide, it will not react. Why it will not react? Any idea? Why it will not react with the sodium carbonate or sodium bicarbonate? Sodium hydroxide will not react with the dilute sodium hydroxide will not react with sodium bicarbonate or sodium carbonate. Why? Yes. Any idea?
Organic compound.
You know it definitely. Yes. In previous experiment, dilute HCl and dilute HCl and sodium carbonate or sodium bicarbonate. They reacted and carbon dioxide is evolved. But here it will not react. Why? Loudly. Both are bases. Is there any reaction?
No, sir.
Always acid reacts with a base, not base, not acid. That is why no reaction in it. Got my point? So this is very, very important. And one more important thing, precautions to be taken while handling or while doing these experiments. Even in part D of your question paper CBSE, definitely they will ask what are the precautions to be taken while doing this experiment. In previous year question paper you can see for 2 marks this question. First one, that is HCl should be handled with care as it causes burning to the skin and causes what we call damages the skin and claws. So while handling HCl, we should handle it with the care. It is highly corrosive, burns